G'day viewers. In this segment we'll talk about things you can do with IP prefixes, aggregating, joining them together, and subdividing them to split them up. Our topic here really is how to help scale the routing of the internet, as well as improve its management, and we can do that by adjusting the size of IP prefixes. And in particular we'll look at two ways to adjust the size. We might split up a large prefix into smaller subnets, or we might join together several prefixes and aggregate them into a larger prefix. So just a little bit of background. So recall that IP addresses, as we've gone through, they're allocated in blocks called IP prefixes, such as this prefix, 1831.0016. And a key observation is the hosts on one network share the same prefix. Now, just as a quick reminder, because they share the same prefix, we can route towards the prefix. That's where we're getting scalability in routing, as we've gone over. Just as a reminder, let's work through an example here. A /n prefix has the first n bits fixed, and so it contains the other 32 minus n bits are free, so it contains 2 to the 32 minus n addresses. So for instance, the /24 will have 8 bits free, so it will contain actually 2 to the power of 8 addresses. Oh, that's not very clear. 2 to the 8 is 256 addresses. And a /16 will have 2 to the 16 addresses in it, and that is, what's that, 64k addresses, 64,000 different addresses, or 65,000 actually if you compute all of the numbers out. Okay, now, the key flexibility that we get from using prefixes is that actually it's routers that keep track of the length of different prefixes. They use it for the longest prefix matching algorithm to decide which way to forward traffic. Now, because it's routers that keep track of the length of prefixes, not hosts, the key flexibility we gain with prefixes is that routers can change the lengths of prefixes without affecting the hosts for the most part. In particular, we can change an IP prefix to make it more specific by lengthening the prefix, turning it into a block which has fewer addresses, so dividing a big block into blocks with fewer addresses. Or we can change the prefix to make it less specific, and we can take several blocks and then join them together into a bigger block, which is the less specific prefix. Well, let's just go over a little bit how that would work. Here is just an example of the sort of thing we're going to do. In this figure down here, we have 3/18 prefixes, IP1, IP2, and IP3. And what we'll do when we use aggregation is we would join those together, for instance, into one larger /16, if all of the addresses were of the right form such that we could aggregate them. That /16 would then represent the whole region here, and we'd be able to route towards that, for instance. So, in fact, there are two different use cases which are really just converses that allow us to adjust the size of IP prefixes. Both of them are taking advantage of hierarchy in slightly different ways, and they'll help us both manage the network and to reduce the size of the routing table. We're really after scalability by doing this. So what are the two use cases? One is that you can do what's called subnetting. You can divide a large prefix which has many addresses into more specifics, multiple more specifics, each of which represents a smaller network. These are then, or a smaller portion of the network. These more specifics, prefixes, are then called the subnets. And in this way, you can acquire a big block of addresses or a block of addresses from your ISP, and you can divide it up into different chunks to help you use it most effectively within your organization. The converse side of this is aggregation. Externally, we might have IP prefixes for several networks, and we might be able to join them together into a more specific, into one large prefix, which is a less specific prefix. We take all of those more specifics and we join it into less specific prefixes, which will represent a larger number of addresses. We can do this if all of the addresses are about right, if they're in the same portion of the address space, so that they could be aggregated. Let's see an example of how this would work. So here, externally, maybe this is a company here. You can see the line is dividing it. The company is to this side, and here's the rest of the internet. So from the ISP, the company has acquired this IP prefix here for all of its computers, 128.208.00/16. So it's a /16, so it has 64k different addresses. Well, internally, it might want to divide that into different structure because often there is structure inside an organization. Here it's a university and we have the E, CS and art departments. So what are they going to do? Well, internally, they could divide a /16 up into a /17, a /18 and a /19. There's actually a little bit left over. Now, I'll let you go ahead and afterwards work out all of the different addresses here, just to see that in fact this block of addresses, if you draw the address space, has been divided up properly. It looks like the /18 here starts at the very bottom of the address range. The /17, it looks like it starts about halfway through the address range and then goes up. And there's also a /19 somewhere in there above the /18. And there's actually a little bit of space left over. It can be a little confusing unless you look at the values of the binary in binary and draw a bit of a map of how the address space has been divided. And here's an example of the flip side. I might have 3 different universities here, Cambridge, Oxford and Edinburgh, have a /21, a /20 and a /22. Now, it just so happens that these prefixes are also chosen from address space, which is quite close. It's all related. In fact, it all forms a larger block. I can aggregate those prefixes so into a single /19 is large enough to contain all of the IP addresses in here. And you can see here's the address of the /19, the lowest address in the /19. And again, to really understand how these prefixes have been joined, you need to be able to write down the top and bottom address for all of these things and see how they relate and for the size of the prefixes and the size of the overall block. But there's an example of subnets and aggregation and adjusting IP prefixes to suit our needs.